Trend analysis in Power BI is the process of identifying and understanding patterns and changes in your data set over time. So it helps you uncover insights into how your metrics are behaving and predict future trends. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master the Microsoft Power BI tool over the next 100 days. Today is day 53. We've been learning over the past 52 days and we've been showing up consistently and not lagging behind and covering new stuffs in within Power BI. So on this live stream, on the previous live stream actually, we started a new course called Trend Analysis in Power BI, which helps you to analyze time series analysis and visualize your data and spot trends within your data sets. So you understand how to build new date variables, discover run charts, and get into calculating rolling averages. So with trend analysis in Power BI, you finally learn how to identify which variables exhibit the most influence on the target variable using Power BI decomposition trees and key influencers. So on the previous live stream, which was the first day that we started this trend analysis course in Power BI, which was day 52, we explored our time series data. So you can catch those lessons on the live stream tab on the channel for day 52. And if you are looking to go start from day one, where we started from introduction to Power BI, you can go to the live stream tab and start from day one till today's date. You'll see all what we've learned and covered so far. So on today's live stream, which is day 53 for the second chapter of this time series analysis in Power BI, we'll get more familiar with time-based variables and multiples way to extract further variables using EDA for analysis. We've covered EDA in our previous live stream also, so that is exploratory data analysis. So for this time series data, we'll learn how to extract variables like days of week and time differences. Also get our hands on with Power BI as we build line charts, calculate new metrics, and uncover trends hidden in your data set. So we're going to be calculating period over period change and rolling averages in this time series analysis. So welcome back to day 53 of chapter 2 of the time series analysis in Power BI. So without further ado, let's jump back to learning. Also, all the data sets or Power BI files, exercise files, is already linked under a YouTube description, under the YouTube description. So do make sure to download those files using the link below so you can practice along with me. So without any delay, let's jump back to learning. So I'll just quickly go to my DataCamp platform and show you what it looks like. So if I quickly run to the career track section real quick, under data analysis in Power BI, you can see we are 72% throughout the whole career track. When we started this learning journey, this fun way of learning, I actually started with data analysis in SQL. So if you are looking to upskill yourself or learn one or two things in SQL, you can just go to the live stream tab. You will see the SQL series also there. So definitely when we finish this data analysis in Power BI, we are moving on to data analysis with Python. So you definitely want to subscribe right now and put on the notification bell so you'll be the first to know whenever I go live like this or drop in new content on the channel to upskill yourself as a data professional. So if I click on data analysis in Power BI real quick, you can see it contains 17 courses estimated for 48 hours, and we've actually covered quite a lot from introduction to Power BI all the way to the 13th course, which is trend analysis in Power BI. We've covered all this practice and practice over and over again. We definitely covered some case study like this, analyzing customer churn in Power BI case study. We also covered this HR analytics in Power BI. And we're actually on this trend analysis Power BI, which is probably like a case study also. So let's continue with the course. We're moving to the chapter 2 part of the course today. So this was what we learned a live stream. So you can catch everything on the live stream tab on the channel where we actually look at how to construct a date, new date, construct a date from parts. We use the left, mid, right, and weekdays function for the dates function actually. We also practice creating new date variables, analyzing trend by different date grains and context, such as day of week, month over month changes. So it was a lot. And we also actually use this period over period chain. We actually calculated year-over-year change or period, calculated percentage between time periods to identify long-time trends using the formula. We also use this formula to calculate period over period calculation, which was quite interesting. So you can catch all of this on the live stream tab, day 52 on the channel. Let's start with the
Howdy.
second chapter.
You now have some initial exploration of time series data and analysis under your belt. Now, let's take a deeper dive into the most frequent type of chart used to visualize this data and relevant metrics for analysis. In the previous exercises, you analyzed time-based variables using column or bar charts. Though useful for evaluating frequency and other metrics between time intervals, such as year and month, as your analysis moves towards a day-level grain, they can become too crowded. The more common and effective graph at this point is to use a run chart. A run chart is a graph which displays data in a time sequence. As you may have observed, it is simply a line chart. Here, we see the New Germany Fund closing stock price for each day between June 2014 and May 2018. The line chart allows for finer detail without clutter. Likewise, it is easier to start understanding the broader trends. Two important types of trend patterns you might observe are cyclical and seasonality. A cyclical pattern exists when data exhibit rises and falls that are not of a fixed period. This pattern will usually occur over more than a year and not be very predictable in when it will rise or fall. Seasonality exists when a time series is influenced by seasonal factors. Example, the quarter of the year, the month, or the day of the week. It is always a fixed and known period. For example, swimming pool attendance increases in the hotter months. Similar to what we did with scatter plots and evaluating relationships, one way to add a visual representation of the trend is a line. Here, the trend line informs us that as time increases, so does the stock price for this fund. However, it is obvious that the stock price does not follow a linear trend, but rather something curvy and nonlinear. A common method for understanding the underlying trend for the time series is known as rolling or moving average. It is the average of the data point values over a specified time window, or the number of days to use in the average calculation. Here, we see the 7-day rolling average of the stock prices as a dark blue line. This rolling average trend is also known as smoothing. It is a technique which helps remove some of the random variation, the sporadic ups and downs, observed in the data. Removing the light gray line representing the underlying data, we are left with the smoother 7-day rolling average trend. The window size can be adjusted to make the trend line smoother or follow the underlying data more tightly. Here, we see a rolling average of 14 days and 28 days. As you may have noticed, the larger the window size, the smoother the trend line. The window size you use for analysis will depend on the data and the ultimate goal. Similar to the distribution of a single variable, outliers can be detected with time series as well. In this case, they are often referred to as anomalies. Looking again at the 28-day rolling average line chart, the dark gray circle highlights a possible anomaly in the time series. We won't be covering the exact math and process here in this lesson. Quite simply, an anomaly is a point in the time series which falls outside of the expected trend. Now it's your turn to build time series line charts and calculate rolling averages.
Okay, so the key takeaway here is that Run charts are definitely also called line charts. Or line charts are also called run charts. So I'm quite used to calling them line charts. Never heard of a run chart before. That's quite interesting. So see cyclical and versus seasonal. So being able to read time series line charts will allow great understanding of the patterns observed within the data. So distinguishing between uh, cyclical and seasonal patterns will help direct further investigation into what is potentially influencing those patterns. Okay, so drag each item into the correct category. Cyclical or seasonality. Pattern recurs under a year. Patterns recurs under a year. That should be this. Cyclical. Patterns recurs over a year. That's seasonal. Ice cream sales. Oh, should you say ice cream sales? I could say ice cream sales are, you are prone to have more sales of ice cream in the outer, well, definitely the outer part, probably the summer, yeah, summer period of the year, where the weather is quite hot. That should be seasonal. Is not okay. Less predictable. This should be this. Vote registration for major elections. Vote registration. Oh, this kind of convince. I think I'm making a mistake here. This ice cream sales. Vote registration for major elections. It should be under a year, not recurs over a year. Fixed time periods. Um, mm, so that should be seasonal. Seasonal are fixed time period. Uh, on fixed time period. On fixed, that should be this. Let's double check one more time. Mm, mm. This should be over a year. It should be on the since it's season now. This should be under a year. Let's log that in. Oh, we got it. Nailed it. So we can see that this pattern, this cyclical pattern or cyclical patterns, quite funny. I couldn't pronounce this. Not funny at all. So these cyclical patterns, it's goes over a year. That is for a year time period. They're less predictable because you can actually predict when it will happen. Like the major election period, they have to choose election period. So they have on time or fixed time periods. Where was it something that is seasonal, could occur quarterly, weekly, or monthly. Definitely like the ice cream sales, they have fixed time periods. That's quite funny. I'm finding it hard to pronounce this word. So congratulations, you're able to identify cyclical from seasonal patterns, a useful skill when interpreting time series data. Time series. Okay, let's continue. Analyzing Glassdoor time. Okay.
Now that we have explored how the number of reviews changes by different date grains and between time periods, let's dive the time series trend. We will do so using run charts, aka line charts. I'll create the first one by choosing line chart in the visualizations pane, then dragging the review date to axis and review ID as a distinct count to values. I'll drill down to the lowest date level to see the complete trend between March through May. To quickly visualize the trend and count of reviews, let's use the native trend line in Power BI. Going to the Analytics tab under Trend Line, then click Add. I'll update the color of the time series from blue to light gray by going to the Format tab, expanding Data Colors, and selecting light gray. The trend line shows a straight, linear increase from the beginning of March through the end of May. However, we can see there is more variability in the light gray time series. We can generate a more accurate trend line that follows the nonlinear pattern seen in the underlying data while also smoothing using rolling averages. This first requires creating a new quick measure. In the pop-up window, Under Calculation, Time Intelligence Options, select Rolling Average. Use Review ID as a distinct count for the base value and Review Date for date. I'll experiment with a 7-day rolling as the general increasing and decreasing trends. Power BI also offers advanced analytics features, specifically anomaly detection, for line charts that help flag potential data points that are abnormal. If you remember from Chapter 1, these data points are like outliers in that they are outside of expected values. To add anomaly detection to our time series, go to the Analytics tab. I'll remove the trend line. Because the visualization has both 7-day rolling average and the count of distinct reviews, Power BI will not allow for anomaly detection. This is an easy fix by removing the distinct count of review ID, leaving the rolling average measure. Now we'll go back to the Analytics tab, expand Find Anomalies, click Add, then change the sensitivity to 98%. Note, the higher the sensitivity, the more abnormal the data points have to be flagged as anomalies. The Power BI anomaly algorithm detected 3 abnormal points. Clicking on the dark gray circles, highlighting anomalies, will bring up auto-generated explanations for why these may be occurring. Dragging other fields, such as gender, into the Explain By section tells Power BI to use the changes or values of that variable for why the anomaly may exist. It seems the number of reviews from females was higher than usual at this anomaly at the end of May. You can see Power BI creates a separate chart with the female-only time series for 7-day rolling average review count. We can create our own, showing also that for males with small multiples. I'll duplicate the existing chart, then drag gender to small multiples. I don't like how the small multiples are in a 2x2 grid, so I'll go to the Format tab, expand Grid Layout, and decrease the number of rows to 1. Compared to males, females had more of a dramatic decrease at the beginning of May, then a sharp increase a week or so after that. Now it's your turn to build time series charts, explore rolling averages, and detect anomalies.
So let's explore rolling averages and detect anomalies. So we are building your first time series chart, calculating rolling averages, and finding anomalies in time series data. Let's give it a shot. Okay. So the instruction, the context. So building your first time series chart. So one of the most ubiquitous visualization in time series analysis is the line chart, aka run chart of a target variable versus a date variable, especially time. So in this exercise, we use a line chart to understand the number of hosts who join Airbnb by day. So let's open our exercise files. Time series coming up. So let's create a new page named time series, then filter the page to only include years 2019 and 2020. Let's wait for that to come up. Okay, so let's create a new page. So this was from the last day 50, the last live stream. We actually calculated missing variables, the sky distribution, modified price, host date key, day of week calculation, and year-over-year change. So quite interesting. You can catch those live stream, those record on the live stream tab on the channel. Let's create a new page called time series. time series. Okay. Then filter the page to only include the years 2019 and 2020. So filter on this page. Let's add the dates. Since dates. Oh, this is the dates. I don't want to add the old dates. If I change it to basic filtering, but this is the basic filtering though. That's only field I need. This is the field that I need. Let's see. Oh, nope. Where's the dates column? I need to find the dates column right now. I could just type it in though. Oh, since the this is definitely the. I will just do the year only, the year part. Interesting. Yeah, got that. So we only want 2019 and 2020, I guess. Yes, 2019, 2020. So we have filter on this page to is 2019 and 2020. Okay, so let's move on to the next instruction. So create a line chart showing the distinct count of hosts over time. We top a line chart or a run chart, aka run chart. So on it, we want to show the distinct counts. You should use variable hosting date, which contains date information. Once finished, resize the graph to fit the page. A line chart showing the distinct count of hosts. Okay, let's see. That should be the host ID. But we want distinct count of the hosts. Then our x-axis should be hosting dates. But we want the year. You can see it is with a line chart. I'll just go a little, I'll just filter down. This is by year. This is by year. Okay. Just year 2019 and 2020. You can see quarter of 2019 to 2020. This is by month. This is still better compared to this by day. And the last one, okay. This by day, by months, by quarter. Let's just leave it by months. You can see the number of people that are joining throughout the months, throughout the year of 2019 and 2020 by the months. Okay, let's see. Drill down to the lowest level of the data hierarchy, which is day, by expanding each level. Okay, let's drill down to day. To the days by month, this by day. Okay. There was a high drop in the last day of the month. That's quite interesting. We have day. Okay, there's no date. Something like the month is just from first day, 30 days. We have 30 days in a month. So this figure here, probably wrong data information there. Okay, add a trend line to the time series chart and change its format to be solid black line. Okay, let's add a trend line. We'll go to the format tab. We go to trend line. Just open the trend line. You can see. Then we have to make the trend line, change its format to be a solid black line. Solid black line. Solid black line. You see, it is black. So line type solid. Oh, we have to change it to solid over here. I hope you can see that solid. We change it to a solid black line. The width, let's leave it at the default width. So instead of dash or dotted, make it solid. Okay. To change the line chart format to use a light gray color for distant host values time series. Okay. Our line chart, we want it to have a light gray color. Let me see, that should be line chart, line chart. Oh, the line here, the color, you see the line here. So the color should be light gray. Let's leave it like this. And let's use this other light gray. I think this is better, the line. Okay, that's formatting. So how would you describe the trend in count of hosts between January 2019 to December 2020? I think it's decreasing. You can see decrease, spike, decrease, spike, then decrease. So it was like of increasing and decreasing. So then finally there was a huge drop. Let's go for decreasing, definitely decrease. We don't want to say neutral. That's right. There's a slight decrease in the count of new hosts over. However, this line doesn't capture the exact non-linearity of the trend. So definitely it was decreasing there. So let's move on. Now let's calculate the rolling averages on the line chart so you can compare the average calculation and know what is actually happening to our time series data. Okay, so let's move on. So using the date or time variable directly may result in a time series with lots of variation. So smoothing can be done with rolling averages. It is 7 days rolling average or 28 days or whatever number of days you want to calculate. In this exercise, you will compare a 7-day versus 28-day rolling average to see which provide a smooth but informative trend. So let's continue. So create a new quick measure to calculate 7-day rolling average for the distinct count of hosts using the variable host since date as the date indicator for the measure. We name the measure to 7-day rolling average. So let's create a quick measure right here. Right here, I want to calculate time series. That should be time intelligence rolling average. So for this, our base value is going to be the host's ID. But that is going to be a distinct count. So our dates is going to be host since dates. Then days before is going to be 7. And this after is going. The good thing about quick measure is all this, you don't really have to understand what is happening here. It is actually giving you the correct calculation. So I'll just log that in. 7 rolling average. So we've done that. So you could see it here. 7 rolling average calculation. So I think we are going to do another 28 days calculation. Create another quick measure. This time calculating the 28-day rolling average for distinct count of hosts. Rename as 28 rolling average. So let's create another quick measure. Another one. Let me just hide this. Quick measure. So let's create another time intelligence rolling average. This time around also, we're going to use the base value as host ID. We want the distinct counts. Our date is going to be host since dates. So this before, that is 28. Days after, that is 0. Then we add that to the calculation. So this time around is going to be 28, not be 28. 28. Let's log that in. So we have two rolling averages calculation right now, which is 7 rolling average and 28 days rolling average. So let's go back to the instruction. Duplicate the time series chart, then add 7 rolling average to one and 28 rolling average to the other. Rearrange to place the chart with 7 rolling average above the other. If we want to duplicate these charts, let's see how we can do that. Okay, let me just make it a little bit smaller here. So we can compare everything together. Oh, we need more space. Okay, that's our normal line chart. Okay, so what do we need to do now? So what do we need to do now is to add, so duplicate the time series chart, then add 7 rolling average to one and 28 rolling average to the other. Okay, let's add to this. I'm going to add the cost of host ID, count of host ID to 7. You can see added it. Ooh, that's kind of like straight. But let's see. Hopefully we haven't made any mistake. It's just straight. How about this? I'll add 28 to this. Almost the same thing also. Probably we need to remove the count of host ID and leave the other one. Okay. Let's go on first. So which of the following average would you choose if you want to remove the most random variation and understand the underlying trend in new hosts? Either 728 or I'll go for neither, but let me just remove uh the first one there. You can see, okay. This is, you can see, once I removed the count of host ID, the ordinary count of host ID compared to the 7. Okay, so this is the 7 rolling average and the 28 days rolling average compared to the normal calculation without the distinct counts. Okay, let's see better now. Like we can spot the difference between the 28 days and 7 days rolling average. Okay. So the question, so you could see here, when we're looking at this from 2019 to 2020, by the way, we could see that there was a slight decrease in us joining from between the years 2019 and 2020 for a period of 2 years. When you look at this also, 7 days, uh, there's a drop, then a spike, drop, spike, drop, spike, drop. So it's still following the same trend: spike, drop, drop, spike, drop, spike, drop. Almost the same thing. But when you look at this, I think this one is there's an increase in the 28 days on average. Oh, this is quite giving us another information. When you look at the trend line, the difference is pretty clear here. So let me look at the question again. Which rolling average would you choose if you want to remove the most random variation and understand the underlying trend in new hosts? Which rolling average would you choose if you want? Okay, saying which one will I choose? Will I choose 28 days or 27 days? I'll go for 28 days. Let's go for 28 days. Correct, that's right. 28 days rolling average removes a lot of random variations seen in the original data and 7-day rolling averages. You can see that the random variation that we are seeing here, that there was a spike, drop, there's nothing like that in the 28 days rolling average. It's just a straight trend. You can see. So we need to understand more. I need to understand more about these calculations. Okay, so let's move on. So finding anomalies in this time series data. So viewing global trends over time are perfect for identifying recurring patterns as well as unusual ones. So dissecting them further can uncover explanations for why these patterns may occur. So in this exercise, you are asked to investigate an unusual drop in new Airbnb hosts. You will do this by first using Power BI anomaly detection, then digging in manually. Okay, let's see. Duplicate the time series page and rename it to anomalies. Remove the time series line chart with the 7 rolling average variable. We want to duplicate this real quick. Duplicates. And we have to name it anomalies. Anomalies. We want to detect anomalies in our data sets. Anomalies. So that's the anomaly. So we have to remove the time series line chart with 7 rolling average variable. Okay, let's get rid of this. Ooh, I got rid of the wrong charts. I was supposed to get rid of this. Okay, so we have the normal and the 28 days rolling average. Okay, okay, we are moving there. So select the 28-day line chart and remove the count of host ID variable as well as the trend line. Oh, okay, select 28-day line chart, remove the count of host ID variable as well as the trend line. Okay, select this, remove the count of host ID. Okay, I'll remove that. Okay, I'm to remove the count. Oh, I'm to remove the count of, I'm to remove the count, even though I've removed it from earlier. Let me just add it back and see what it looks like. Host ID, the distance count. Then like this, then we added the 28-day rolling averages. Then it's actually affected the charts. But when I removed it earlier, oh, probably I'm supposed to add it as a secondary axis, but I doubt so. But let's remove the count of host ID. I've actually removed this earlier before. That was how I was able to answer the questions earlier. So variable as well as the trend line. So we have to remove the count and the trend line. So let me remove the trend line. The trend line from here. Let me go to the format tab real quick. The trend line. Okay, we've gotten rid of the trend line. Okay. Now we have the normal 28-day rolling average here. Then the instruction then says select 28-day rolling average time series line chart and use the visualization analytics to find anomalies with a sensitivity of 98%. Okay, we want to look for anomalies. How do we do that? I think we have to go to the format tab also. Under, is it under forecasts? No, I'm not forecasting. It's not under forecast. I think it's under error bars. Let me see how the instruction did that. I could just search for anomalies there. Anomalies. Okay, this is here. Where is it hiding though? Oh, where do I find it? Okay, this is here. Find anomalies, but it is not. It is graded out. Why? Oh, why do I enable it? It's actually graded out. Okay, I need to look for how to enable it. Hold on a minute. Few seconds. Now the challenge is how to look for anomalies. Oh, okay. Let me just focus on looking for this. But I'll just need to go back and see how the instructor actually did that in the video. Okay, let me quickly watch that.
Now that
Let's fast forward to here. Find anomalies. It was grayed out
for
initially.
anomaly detection. This is an easy fix by removing the distinct count of review ID, leaving the rolling average measure. Now we'll go back to the Analytics tab, expand Find Anomalies.
I did same thing similar. I did the same thing. I don't know why mine is not allowing me to look for anomalies. My anomalies is graded out. Why? This is not fair. I see the anomalies is actually graded out. Same thing here. What was the problem? Why? What's the challenge? Why is it graded out? I should remove it. I can't. The anomalies won't be available again. Do you see? Then if I should add it back, the pin is now here, but it is actually graded out. Why? Oh, this is kind of challenging. I don't understand why. But wait a minute. I think if I want to add the anomalies, I need to make sure the line chart is there. Even when the line chart is there, the trend line rather is there, the anomalies is still graded out. Anomaly detection only works on visuals that have a date time value or a valid date hierarchy value in the axis field for now. I have a valid date time value here. So there's a date time value here. Is it not seeing this as a date record? Why? Let me look at my table real quick. This OSIN's date is actually a date time data type. Can you see? Format as dates. Then definitely what is wrong is actually from Power BI, but I'm not that sure. Hmm. What could not be the challenge now? It is a date, can you see it is seen as a date hierarchy. Then why am I not having my anomalies detention active? Oh, this is quite challenging though. But I can't do anything without these anomalies being active. Oh, this is not fair. I can't create select 28 day rolling average time series line chart and use the visualization analytics to find anomalies with a sensitivity of 98%. Line chart and remove the cost ID variable as well as the trend line. We've gotten rid of the trend line though. We don't have a trend line here again. So the anomalies should work. Oh, what's not the solution right now? Okay, let's see. If I try to convert this table to only date period, dates, and this is, I hope my data point is safe because you see the same thing though. Oh, this is not fair now. Come on. What can I do now? Let me see. Don't save. Let me see. Maybe if I close it. and open it again. It's going to work fine. So we are back to the page. And let's see now if, because my actual, this column is actually a date and time column. And according to the anomaly format option, find anomalies, it only work for on visual that have a date time value or a valid date hierarchy value in the axis field for now. We actually have that in the axis field. But let me see the instructor on real quick.
Of that variable is the sensitivity leaving the rolling average. Power BI will not allow for anomaly detection. This is an easy fix by removing the distinct count of review ID, leaving the rolling average measure. Now we'll go back to the Analytics tab, expand Find Anomalies.
You see exactly what I'm doing. Same thing the instructor is doing. We have no idea why. Okay, let me just enable do that mode. Drill up. Let's drill up a little bit. Value to the year. Oh, I got it. So I think that's why it's good to always publish. You can see the anomaly detection is now active. But let me drill down and see. Oh, if I should drill down to the quarter, to the month period, to the day period, the anomalies is getting grayed out. Anomaly option is getting grayed out. Okay, so let's do back up or other. If I switch off the drill down mode and I just use the normal, you see the anomaly is now active. If I drill down to the quarter part, to the month parts, to the day level, then the anomalies is grayed out. So let us just drill up for this. Let's see. Probably when we forecast the anomaly, then we can just uh drill down again. Okay. Okay, we've drilled up now. Now let's see, anomaly is now active. Okay, now let's see what we can do with it. Okay. So according to the instruction,
Click Add, then
okay, add
change the sensitivity to 98%.
sensitivity to 98%.
Note, the higher the sensitivity, the more abnormal the data points have to be.
Okay, now let's do that. So sensitivity should be, we click on add. What are we adding? Sensitivity option, anomaly or the color. Okay, the expected range. Explain by, you can actually explain it by, but what it first did was just setting the sensitivity to, okay, let me
Expand
say again.
Find Anomalies. Click Add, then change the sensitivity to 98%.
Okay, I already switched on the anomaly button, so I should switch it off. It is not there, so switch it on. It is there. I'll just change it to 98%. Okay, then I'll explain by, how to explain by a certain category.
Note, the higher the sensitivity, the more abnormal the data points have to be flagged as anomalies.
Okay, then I need to apply my 78%. First, 98% apply. Not window. Okay, let's hold up.
The Power BI anomaly algorithm detected 3 abnormal points.
What if if I drill down, my anomaly is not going to work again. This is not fair. What we want is for the anomaly to work on the day level to detect any abnormalities. You can see that it is now working back again. Okay, let's see though.
Clicking on the dark gray circles, highlighting anomalies will bring up auto-generated explanations for why these may be occurring. Dragging other fields, such as gender,
Let's move on though. Move the 28-day rolling average time series chart to the top of the page. Make a copy, then create small multiples by city. You can see. So I can't complete this part of the challenge definitely because my anomaly detection is not working. Oh, use the visualization analytics that have changed over time. Let me add the city though. Nothing is changing. Mm, mm. That means the why the anomaly is not working. Probably it's because it has been updated. There's been an update to Power BI, and this video was probably recorded when the anomaly is still found under the analytical pane of Power BI. Definitely that's why. That is the best explanation for it. I'll have to look for a solution to this another time because I can't find a solution to this right now. My bad. My bad. My bad. My bad. So I'll just switch off this anomaly detection that is there. So it's not working as it should work on the day level. On the day, you can see the anomaly is graded out. Probably I need to, the DataCamp team, if you are definitely seeing this, you need to update this part of the course as this is not working as it should be. So I just find a solution to it offline or definitely troubleshoot it later another way or look for YouTube videos explaining the new anomaly detection in Power BI. Alright, so that will be the end of the live stream for today. As you can see, there's quite a little bit of challenge, probably due to the updated version of Power BI, and the DataCamp team is yet to update that part of the course. But notwithstanding, they did a great job. So far, so good. The courses are well explained with a lot of practicals to do. So thanks for staying to the end of the live stream. So if you enjoyed this live stream and learning journey with me, do what to support the channel by giving the video a thumbs up, hit that subscribe button, put on the notification bell so you'll be the first to know whenever I go live or upload new content on the channel. And I will see you tomorrow, day 54, as we continue our journey understanding trend analysis in Power BI. Do have a wonderful day. As usual, welcome back to the channel. Welcome to Exile Island.